Hello, and welcome back to the Ninox Learning Series. This is the first class in the 300 level series of Ninox training videos. And in this group of videos, we're going to talk about tables and table relationships. We're going to look at all the different kinds of tables that we have in Ninox and the different links that we can build that allow us to share data and content across those tables and within the scope of an entire Ninox application. Now, before we go any further, I want to study a couple of key terms. I want to go over a little vocabulary so we all know that we're using the right words and we understand the meaning of those words as we begin to have these conversations about tables and table relationships. Let's start by looking at a basic table relationship, the parent-child relationship. Here we see three tables: the customer table, a sales table, and a sales line item table. This is what we would generically refer to as a stack or a table family. The customer table is the parent within the family, and there are two children: a sales table, which are all the things we sell to each of our customers, and a line items table, which are all of the individual lines on each individual sales invoice. If you look at this picture from outside in, we would refer to the customer table as the parent table. The sales table is a child table, but also a parent, and the sales table's child is the sales line item. This is three generations of tables, with the sales line item table not only being a child of sales, but a grandchild of customers. We don't need to worry too much about the child and great-grandchild relationships. What is important to understand is this concept of a family or a stack of tables. When we refer to a stack or a data family, we are referring to all of the data in all of the tables that are related to a core function or a module. In this case, on screen, we see the sales function. And what we see is three different tables related to each other. A parent table, which defines all of the customers who buy our stuff. A child table, which is an actual sales invoice. And then within that sales invoice or sales table child, another child table, which defines each individual line item within the invoice. Now, let's look at a different kind of link between two tables. Here we see a similar relationship between two tables, but these are two different tables in two different families. Instead of one table being nested inside of another to represent that parent-child relationship, we see here two parents or two stacks, a customer and an employee parent table. These are both members of different families or different stacks. By definition, they are parent tables. It is not necessary for a parent to have a child. It is only necessary for the table to exist. In a stack with only one table, that one table is both the master table and the parent table. In this relationship, we see two parent tables or tables in two different stacks or families relating to each other. The table on the left, the customer table, is the name of the entity or individual that purchases our products. The table on the right, the employee table, lists all the people that work in our company. Now, among the people that work in our company are salespeople. And if you look at the last field at the very bottom of the customer table, we see that there is a salesperson field. This lets us know which salesperson, which employee in our company is responsible for handling each customer in the customer table. The need for that relationship, the need for us to understand who in our company manages the relationships and activities with the other companies with whom we do business, demands a link. It demands a relationship between these two parents or these two families. Now, as opposed to the previous link where all of the relationships were in one stack or one family, in this relationship, we're going outside of a single family to bring multiple families together. One set of families, one set of tables is in the customer module. The other one would be in a human resource or an employee or company management module. Now, it is possible, and in fact quite common, for these two types of relationships to exist at the same time. Here we see our original stack: customers, a sales table that records the items and the transactions sold to those customers, and a line items table that details out each individual item sold on each individual invoice in the sales table. But then we see this field here, the item number field in the sales line item table. This table relationship is reaching out to a table in a different stack or a different family. In this case, the inventory or materials handling family. What this relationship represents is a customer bought something. That purchase was recorded on the invoice in the sales table. That invoice had multiple line items, one line item for each item they purchased, and the details of each item purchased, its description, its price, its cost, maybe a picture, any additional information is stored here in the inventory master file. So we see two kinds of relationships coexisting: a parent-child relationship and an external relationship where two families, in this case the child sales line items, related to the parent of another stack or family, in this case the inventory family. So let's review a couple of key terms. When we talk about a stack or a family, we're talking about a group of tables that are related by virtue of the events or transactions or occurrences that happen amongst the tables within that family. When we talk about links, we might talk about a parent-child link, which is the relationship between two or more tables in one stack or family. Or we may talk about external relationships where multiple families are linked together, as we see here on screen. We see a parent-customer table with a child and a grandchild, where the grandchild is linked to the parent of another family or stack. Two other terms that I want us to be very comfortable with are the concepts of master data and transactional data. Now, a moment ago, we were talking about tables, stacks of tables, parent tables, child tables. Now I want to talk about the specific kinds of content or data that exists within a table, because the nature of that content will often determine what kind of table it is and what kind of links and relationships we have coming from and coming to each individual table. Master data tends to revolve around entities. It tends to revolve around singular artifacts, where transactional data tends to revolve around events, activities, or occurrences that were affected by or have an effect on the artifacts within the master table. Let's look back at an example of this master transactional concept here again in this picture. The master record is the customer. This is the entity or the individual with whom we've done business. The other master table in this picture is the inventory table. These are the things or the items that we sell to our customers to create revenue to make our business function. The other two tables, the sales table and the line item table, are transactional tables. These represent events that exist because a customer, because an entity in this master table purchased an item, which is an entity in this second master table. Transactions most often establish relationships between the contents of master tables. Here we see this sales transaction creating a relationship between an entity that is our customer and an object which is the product that customer purchased. So when we talk about master and transactional data, just keep in mind these concepts of things and activities. Things are most often stored as master data in master tables. And again, we've also used the term parent table, and we'll use parent table or master table interchangeably, where events, activities, and occurrences, that information is recorded in our transaction or transactional tables. So we have families or stacks, parents and children, master and transactional. These are the key terms that are important for us to understand as we engage in any conversation about tables and table relationships. Now, let's dive into Ninox and see these tables and these various kinds of relationships in action. Okay, let's take a look at Ninox. Now, we're going to work with a very basic database that we've put together that has the same table structure or examples of the structures that we were looking at just a moment ago. Let's look at the 6 tables that we see on our desktop. We have our customer table. These are the individuals and the companies that purchase our goods and services. We have the inventory table. Again, this is a master or a parent table that has all of the details of the products that we sell. We have our invoice table. This table connects customers with the inventory they purchase. And this invoice represents the event or the transaction that transfers our inventory into the possession and ownership of our customers. We'll skip over state and come back to that in a moment. Finally, we have our vendor table. This is the company or the groups that supply us with our inventory. They sell it to us, we track it in inventory, and it stays in our inventory until we eventually sell it to our customer. We have warehouses. This is where we store the inventory that we purchase from our vendors, and this is where it physically remains, again, until it is sold by virtue of an invoice to a customer. Now let's come back and look at that state table, because this state table is relevant to other tables within our model. The customer, the vendor, and the warehouse tables. These are master tables that talk about or store information relative to specific entities. Our customers, our suppliers, and the physical locations where the goods that we buy and sell are stored. What all 3 of these tables have in common is they are a physical location. And within that physical location or address is a state. So we have this state table, which has all of the states where we have customers, vendors, and warehouses. It allows us to add a geocentric or a geographic dimension to our database. We have parents. In a moment, we're going to see children and even grandchildren. We're going to see transaction and master data in action. Let's look at our data model. Now, when we talk about links and relationships, they are represented graphically in Ninox in one of 2 ways. Relationships across families, or relationships between 2 separate stacks, are represented with a black arrow. The arrow starts at the stack that requires the data, and the arrowhead points to, and the line ends at the table that provides the data. Parent-child relationships are represented where by an enclosure, by the fact that one table exists inside of another. For example, we see this invoice family. This invoice family consists of 3 tables: the invoice, line items that detail the invoice, and all of the different locations where the goods purchased on each line item are to be shipped and delivered. Here we see a parent, a child, and a grandchild, with the invoice line items table actually having two different identities. It is both the child of invoice and the parent of ship to. We'll talk more about how we determine who is a parent and a child, and when we have familial relationships inside of a stack or family versus relationships that go outside of the stack in a moment. But the other thing I want to point out is where this family, the invoice family, consists of a parent, a single child, and a grandchild. This family, the customer family, consists of a parent and two children. There are no third generation or grandchildren tables. We have the customer. This is a master table representing the entities, the individuals and organizations that buy our goods and services. And each customer has contacts, people that work at that organization, and stores, locations where we deliver our goods and services. So, let us review. We have, in this particular picture, 6 stacks or 6 families of tables. The warehouse table, invoice, inventory, state, vendor, and customer. Each of these is a parent table. Each of these represents a stack of data. 2 of these stacks, the invoice and customer stack, are what we call multi-generational, which is to say they have tables inside of tables where we have multiple generations within a family. Remember, a table does not require a child to be a parent or a master table. However, children or child tables must have a parent. Let's look at that in a little greater detail. If there were no invoice, there would be no invoice line item. This invoice line item or child table requires there to be a parent invoice before any content can exist. Without the parent invoice, there would be no children or child line items. Similarly, if we have a customer, that customer may be subdivided into stores. Now, we can have a customer with only one store, which is to say a customer table, a parent customer table with no children. However, if there's no customer, if there's no parent, then there's no children. There are no stores. We can have a customer that only has one store, but we can't have any stores if we don't have a customer to own and control them. So, to review again, we have parent or master tables. These are the tables that track specific pieces of information or fields of information about entities or objects, warehouses, pieces of inventory, vendors that sell us our goods, customers that buy our goods. Those are all parent or master tables. Invoice line items and the invoices that represent transactions between customers who buy and the inventory that they purchase, these are what we call transactional tables. Now, remember, whether you are a parent or a child does not determine whether you are a master or a transactional. Here we see a parent table, the invoice table, that has children. The children and the parent are transactional. Multiple invoices can exist for a single customer. One customer can buy more than one thing from us or have more than one purchase event. At the same time, each purchase can be for multiple goods or services. Therefore, they could have multiple line items. But this is an event. An invoice is an event. An invoice line item is the details of an event. This is a transactional table. The customer table, on the other hand, is an entity. It is an organization. And very often, there will be many, many transactions for a few or even one customer. We may have 10 customers, and each of those 10 customers may buy 5 transactions from us a year, and each transaction consists of 5 individual line items. So we have 5 customers, each one with 5 invoices. So we have 25 invoices, and each of those invoices has 5 line items. 5 customers, 25 invoices, 125 line items. A few customers, a few pieces of master data will often be related or linked to many, many pieces or many records of transactional data. And in terms of links and relationships, we have inside the family or stacks or families of tables, and we have links across families or across tables. As we see, for instance, here, this warehouse table is where we store the contents of our inventory. This is where we store the goods and services. The warehouse is a physical entity. It is an address where things are contained. The inventory table, that's the detail of the things contained in the warehouse. 2 different parent tables, 2 different master tables, 1 link between them. Now, let's look at a couple of other things before we conclude. Let's take a look at this relationship right here, where we have one child linked to another child in the same family. In this relationship, what we are demonstrating is that customers have multiple people working for them and multiple stores. Each store might have a single store manager. That store manager is an employee or a contact within the customer company that has the store. So let us assume that the Acme company has 100 stores and 500 employees or contacts, about 5 employees per store. There will be 1 customer record for the Acme company. There will be 100 store records for each of the 100 stores that make up the Acme company portfolio. Think of it this way, 500 addresses where the things they buy need to be delivered. And then finally, there will be all of the employees or the contacts that work for the Acme company. And some of those contacts will be managers of these stores. So there is 2 relationships happening concurrently, all within this customer stack. Stores and contacts are the children of the parent customer. So they have the relationship of being siblings, but they also have a second relationship where one of the individuals, one of the records in the contact table, is actually the manager of a store. These 2 children are related to each other by virtue of having the same parent, they're part of the same customer, and by virtue of the fact that one of the records here is the name of an individual that manages one of the stores down here. So what do we have? We have parent, child, grandchild. We have parent to parent. We have child to parent. And we have child to child. All different kinds of relationships. How we build those relationships and the buttons we click and the actions we take to make these relationships work, that's what we're going to talk about in the next video. But in this class, what's important for you to understand are the 2 fundamental concepts of tables and the type of content within the table. Tables are referred to as master or parent and child. They are collectively referred to as stacks or families. And then we also have the reference to the type of data or the type of content in those tables. Transactional content, which represents the details of events, occurrences, or happenings, and master data, which represent the entities, the organizations, the places, the things that are the objects of the events and activities represented in those transactional tables. If this is confusing, take a second, rewind, watch the video again. These are important terms, and it's critical for you to understand these as you dive deeper and deeper into building the relational components of the relational databases that are the very foundation of the Ninox relational database management ecosystem. That's it for this video. Check out the next video where we will go step by step and build all of the relationships across all of the tables that we studied and looked at in this class here today. Thanks for joining me. If you've got questions, watch the video again or shoot us an email if you'd like to talk with us. And if you're ready to move forward, head off to the next video and start building those table relationships and building the relations that are the foundation of the relational database management system that is Ninox. Thanks very much. We'll see you in the next class.